In this video, we will see that how we can perform a modeling for the segment-wise tapering of a particular tapered member. And for that example, we are having a two cross sections. So if you go to the modify and you will see the PSC box section at the start of the PSC box girder tapered member, and at the end of that particular tapered member, we are having this type of section. Now, let's say we want to create a segment of 3 meter, and currently the span length of this particular curve library path is 30 meter. If you go to settings, you can see the span is assigned as 30 meters. Now, to create some segments, first we need to create planes and constraint paths. So for that, we'll go to constraint plane option. Under that, we'll choose by offset option and we'll select this particular constraint plane. We'll assign the offset distance as 9 at the rate 3 meters. We'll choose by distance option, or we can also go for the by ratio as per your requirement. Currently, I'm going for the user defined reference point location, and we'll assign the value as 0.5, and we'll click on green tick to create the constraint planes. Now to create constraint paths over those particular constraint planes, I will go to path option under the curve library ribbon. We'll select all the constraint planes and we'll click on green tick to apply the changes. Now we are having a constraint paths, we are having user sections. So now we will head to create a tapered member. So first of all, we'll go to path linked entity option and we'll click on create plane type option. Under that, we'll create an entire tapered member starting from the 0 meter location to the 30 meter location with a cubic parabola profile. So for that, we'll choose default constraint path, which is starting from 0 meter and ending at 30 meter location. We'll check on this tapered section option. At the starting, we'll assign the S1 profile, and at the end section, we'll assign S2 profile. Over here at the top under the create section, we can assign the variation of tapered member under this option. Under the local Z, I want to assign the variation as cubic parabola. We'll click on preview and we'll click on green tick. So we have created a particular tapered member starting from this location and ending at 30 meter location with a cubic parabola profile using two user section profiles. Now to create segments, we'll first need to create some user section profiles. So for that, we'll go to base ribbon. Under the base ribbon, we are having a user section option, and under that drop down menu, we are having an option called extract. We'll click on it. We'll assign the profile name as S1-1, and under the define plane option, we'll choose 3 points option. We can also go for the curve normal option and plane by offset option. Currently, we are choosing 3 points option. We'll choose the type of plane as S, which is side plane. We'll press S key on the keyboard to activate it. Now at the center of this constraint plane, on the constraint path at this particular location, we'll mark our first origin, second in the Y direction, and the third point we'll click in the Z direction. Now we'll select this member as a target and we'll check on this reverse direction option so that this peak option shall appear. Now we'll click on this option and we'll point that particular location which we have selected as a origin for the 3 points mark. After that, we'll click on add button to add this particular profile. If you go to work tree over here under the data ribbon, we can see we were having S1 and S2 as our predefined user section profiles, and now we have created S11 profile. Similarly, we will be creating all other profiles. So for that, we'll again go to by 3 points option. Now for the second constraint plane, we'll mark this as a center, Y, and positive Z. We'll select the target, we'll check on the reverse direction, and we'll pick the same location of origin. We'll assign the name as S12. We'll click on plus, and similarly, we'll follow the same procedure. After creating all the profiles, you can verify them, the values and the reference point location with respect to the datum point. Now, after extracting all the user section, we'll select this member and we'll press the delete key on the keyboard to delete this entity. Now we'll go to top view and we'll head to a curve library ribbon. Under that, we'll choose path linked entity option and we'll click on create plane type option. Now we want to create different segments. So first of all, we'll choose main constraint path option. We'll select the first main constraint path. We'll check on the tapered section option. So first section, the profile would be S1. We'll click on assign. And at the end section, we'll be having the profile of S11 and we'll click on assign. Currently, we are not assigning any tapering variation. We'll discuss it later that why we are doing that. Currently, we are just assigning as a linear variation. We will click on add button. Similarly, we'll select the second main constraint path. At the start section, the profile would be S11. We'll click on assign. And at the end section, the profile would be S12. We'll follow the same process till the end. Over here, the profile would be S12, 13, 13, 14, 14, 15, 15, 16, 16, 17, 17, 18, 18, 19, and 19 to S2 profile. So we'll assign those particular members. Now we'll click on green tick to save and exit the menu panel. Now if you go to front view option, so you can see the linear variation is there, but we want a smooth curvature of a cubic parabola at this particular location. Each of the members are converted into a particular segment length. Similarly, we can create the segments for the PT, the peer table segments, and FSM and FCM sections. For now, to create a smooth curvature over here, we'll go to path linked entity option and we'll choose variation group option. We can assign a group name. We'll choose all the members using the cursor cross selection. The path origin, the path location would be a variation origin. I'll choose local Y for the user defined and I'll choose the first constraint plane as a symmetric plane. And under the local Z, I'll also go for the user defined and I'll choose the same constraint plane as a symmetric plane. Now under that profile, we are having two options. One is for the curve direction, either we want to go for the positive or the negative one. Currently we are choosing the positive. And under the variation type, we are having four options mentioning about linear, parabolic, cubic, and polynomial. Currently we want the variation to be as cubic parabola. We'll select this option. And if you go to front view, and I'll click on blue plus button to add this particular variation into these members. So you can see a smooth curvature has been defined at on this particular segments. So this type of variation groups can be created for the smooth curvatures. So this is how we can create segments for the particular tapered member in CIM using only two sections, one as a start profile and another one as an end profile. We can create different user sections, we can extract them, and at the later stage, we can create a tapered member using all these particular sections. And after that, we can assign a variation group as per our requirement. We can also go for the parabolic curvature or any other polynomial curvature.